Football is a game of brute force, tradition, and toughness. But in the last 2 decades, something else has crept onto the field: technology. The NFL, once dominated by chalkboards, grainy tape, and gut instinct, is now a billion-dollar tech playground. RFID chips track players' every move. Cameras fly over the field on cables. Referees review plays with help from AI. And that's just scratching the surface. Today, over 250 million data points are tracked in a single season. Games aren't just played, they're engineered. And whether you're a diehard fan or a casual viewer, you're witnessing a sport that's quietly transformed itself into one of the most technologically advanced enterprises on the planet. But how did we get here? And what does it all mean? This is the story of how technology quietly took over the NFL, from the sidelines to the broadcast booth to deep inside the helmet. Let's start with what fans see every Sunday. Because while players may steal the spotlight, it's the cameras, mics, and augmented visuals that shape how we experience the game. You've seen it hover above the action. You've seen it zip along the sideline tracking a 50-yard bomb. That's the Skycam, a suspended camera system that's revolutionized how games are broadcast. The Skycam was invented in the 1980s by a guy named Garrett Brown, who's also created the Steadicam, which is seen and widely used today on the field and in Hollywood. Brown's next idea, a flying robot camera that could give fans a full field view that felt like they were actually inside the game. It made its football debut at the 1984 Orange Bowl, Miami vs. Washington. And while it was cool, it wobbled like crazy, lagged behind plays, and just wasn't ready for prime time. So the NFL and college football shelved it. For the next 15 years, Skycam was just a gimmick, used in commercials or action movies. Then came the XFL in 2001, a league that flamed out in one season, but gave us the most important innovation in sports TV since instant replay, the new and improved Skycam. The system uses 4 motorized winches and high-strength Kevlar cables to maneuver the camera across a 3D grid above the field. Operators use a joystick controller and specialized software to fly the camera smoothly without disrupting play. The XFL made the Skycam their main camera. They strapped it behind quarterbacks. They chased running plays with it. And for the first time, it felt like you were inside a Madden game. NBC saw the potential, and when they got NFL rights again in 2006, they brought it back for real. At first, it was just a flashy replay angle. Then it became a mainstay on Sunday Night Football. And now, it's used in nearly every primetime game. The tech behind the Skycam has improved big time. Mapping stadiums before every game, technicians create a virtual grid of the field and calibrate the camera's flight path. It's suspended by 4 high-strength Kevlar reinforced cables anchored to winches at the 4 corners of the stadium, typically mounted on catwalks or towers way up in the rafters. Those winches are smart motors. Each one is computer controlled, reeling in or spooling out cable down to the millimeter, dozens of times per second. By adjusting the length and tension of all 4 cables simultaneously, the system can move the camera in any direction. The rig is so responsive, it can accelerate from 0 to 25 miles per hour in less than a second and stop on a dime. The rig itself is usually a Sony camera, mounted in a 3-axis gyro-stabilized gimbal, which cancels out swing from the cables, vibrations from rapid movement, and wind or stadium air currents. It takes a team to operate the Skycam. The pilot flies the rig using a joystick and throttle, almost like flying a drone in a flight sim. The camera operator handles framing, pan, tilt, zoom, focus, exposure, and a safety tech monitors weather, altitude, and emergency lockout systems. And behind it all is the software, built with virtual geofences, pre-programmed paths, and emergency protocols in case a winch fails or a rogue fan lets off a drone. Another pivotal broadcast camera, but one that is considerably smaller, is the pylon cam. The tiny cameras hidden in the goal line pylons, sometimes as small as a lipstick tube, offer some of the most dramatic replays in the sport. Each pylon contains multiple small HD cameras, usually 4 per pylon, angled outward to cover every edge of the end zone. These cameras are wired through the turf and connected to broadcast trucks outside the stadium. The NFL first tested pylon cams in the 2015 playoffs, and due to overwhelmingly positive reception, began using them league-wide in 2016. They're weatherproof, shockproof, and able to survive full-speed collisions from 250-pound players. But their replacement has sparked debate, because they're positioned outside the actual sideline boundary. They don't technically provide a perfect view of every play, especially when a player's toe is near the white line. Still, they've become essential for reviewing goal line touchdowns, toe drags, and fumbles. Beyond the Skycam and pylon cams, the others used don't get nearly as much shine, but are just as important for the broadcast that we see. NFL games are covered with a massive arsenal of cameras. On average, a nationally televised game might have 30 to 50 cameras in use. This includes 8 to 10 handheld sideline cameras, 2 to 4 Skycam units, including backups, 12 fixed cameras from the press box, end zone tower cams, robotic cameras above tunnels or in catwalks, and super slow motion phantom cameras. And the last one mentioned are arguably the most important. The Phantom Flex 4K is a staple for high-end replays. It can shoot up to 1,000 frames per second at 4K resolution. The result? Ultra-slow replays that show every fingertip catch, every blade of turf displaced by a cleat. These setups are incredibly expensive. A full Phantom camera rig, camera, tripod, operator, controls, lenses, and power gear can easily cost over $300,000. How about the yellow first down line? That was introduced by Sportsvision in 1998. How did it come about? We'll tell you. But the reality is, it changed everything. It wasn't just an overlay. It was a revolution in broadcast augmentation. The idea came from the NHL, actually. Remember the Halo puck? The circular highlighting of the puck to make it easier to track? Many hockey fans do, as it was met with a ton of criticism and didn't last very long. The NFL saw this technology, but had an entirely different use for it, the yellow first down line. But how is this line created? The line is inserted using a combination of field monitoring, mapping the stadium dimensions, camera telemetry, tracking pan, tilt, and zoom data in real time, Chrome key software that distinguishes field turf from players. Before every game, teams calibrate their systems by scanning the field and storing a 3D model. Any camera that's going to show the L line has to feed real-time tracking data back to the graphics software. But there are quirks. If a player's jersey is too close in color to the turf, parts of them can accidentally be keyed out. Also, rainy or foggy conditions can mess with the contrast and visibility of the AR graphics. Over time, more graphics have been added. Field goal range overlays, real-time route trees, QB passing heat maps, and even live win probabilities. Whether it's super sky cams, tiny pylon cams, super expensive slow motion cameras, or yellow first down lines, the NFL's incredible visual systems bring the sights of the game from thousands of miles away directly to our television screen. Yet, all this would be nothing without the other prong of the broadcast, the audio. Capturing the sound of the game is an art form. The NFL uses parabolic microphones along each sideline, those big satellite dish-looking devices. Ambient stadium mics to capture crowd reactions. Anywhere from 8 to 10 mics embedded into the field turf and goalposts. And also, the players can be mic'd up. Only a few players are mic'd up each game, selected ahead of time by NFL Films or team PR departments. These players wear tiny lav mics, often inside the chest plate of their pads, with a wireless transmitter strapped to their lower back. All audio is routed to mixers and delay units in the broadcast truck, where technicians can filter, censor, and EQ the sound live. This is why you hear the crunch of pads and helmets in high clarity, but rarely hear a full string of trash talk, unless it's a mic'd up segment. There have been a few notable moments where mics fell out, caught curse words, or accidentally picked up sideline strategy. In one game, a referee's field mic stayed on for an entire timeout, airing an awkward coaching discussion that wasn't meant for the public. The NFL walks a fine line between access and protection, but the result is some of the best sports audio in the world. Okay, so we've covered the audio and video coverage of the NFL. Is there really any other technology? There is, actually quite a bit more. And instant replay, everyone's favorite feature, just got a whole lot better. Instant replay was introduced in the NFL in 1986, but was inconsistently used, and ultimately scrapped in 1991. It came back in 1999 in a more formalized system with coaches' challenges and a replay assistant. Now, reviews are powered in part by Hawkeye, a system originally used in tennis. Debuted during the Hall of Fame game on NBC, on-field spots have gotten a whole lot better, and it's all made possible by insane technology. It uses multiple high-speed cameras mounted around the stadium to track player and ball movement in real time, triangulating positions using computer vision. Each review goes to NFL's centralized replay command center in New York, where officials and league personnel review every angle. Hawkeye provides virtual renderings of plays, which assist but don't yet replace human judgment. Additionally, the league is experimenting with optical ball spotting, which could allow computers to mark the exact location of the ball after each play, removing human error from one of football's most critical tasks. Debuted during the Hall of Fame game on NBC, like we mentioned, on-field spots have gotten a whole lot better, and it's all made possible by insane technology. Thanks to these systems, reviews are faster, more consistent, and now able to consider angles the stadium cameras alone can't provide. Beyond the cameras and microphones, there's a ton of other technology on an NFL football field, including the players themselves. On the surface, NFL uniforms look pretty familiar: jerseys, helmets, cleats. But hidden inside, a growing arsenal of sensors, transmitters, and analytical tools. Most of this tech isn't used during live games yet, but it's already transforming how teams train, recover, and strategize. Every NFL player wears 2 small RFID chips on game day, one inside each shoulder pad. These tags are part of the NFL's partner with Zebra Technologies and are tracked by radio frequency sensors installed throughout the stadium. Combined, they produce up to 100 positional updates per second for every player. That means player speed and acceleration, distance traveled, separation from defenders, real-time formation, and route mapping are all detected by these chips. The NFL calls this system Next-Gen Stats, and it's used during both live broadcasts and post-game analysis. TV broadcasts use it for graphics like fastest ball carrier or route trees, but teams also get access to deeper layers of this data to study matchups, stamina, and movement patterns. For practices in training camp, teams take this further with GPS tracking units placed in a pouch between the shoulder blades. Companies like Catapult and Connexon offer sensors that add heart rate, load, and biometric strain data. This helps coaches manage player workload, reduce soft tissue injuries, and track recovery. Some teams set daily player movement quotas. If a player exceeds their typical sprint threshold, a sports scientist may pull them to avoid injury. Going even further, modern helmet companies are embedding sensors directly into the padding and shell. Brands like Riddell include multi-axis accelerometers and gyroscopes that measure the G-forces and angles of every hit. These sensors log impact location, impact force, number of hits per session. While these helmets aren't required by the NFL, they've become more popular at the college and high school levels. In the NFL, some teams use them in practice to build impact profiles for each player. That data helps trainers flag risky trends, like alignment consistency absorbing hits to the same temple, or evaluate helmet model performance. Sensor locations vary by manufacturer, but most are placed in the crown at the top, in the front forehead area, in the sides, the temples, and at the base back of the skull. The collected data isn't used for live medical decisions yet, but it helps teams intervene earlier or customize drills to avoid long-term risk. The NFL has also began testing smart mouthguards, developed by companies like Prevent Biometrics. These contain tiny sensors embedded near the molars that detect linear and rotational acceleration, providing a clearer picture of how the skull actually moves during contact. Why the mouth? Because it moves with the skull, unlike helmets, which can shift or rotate independently. These mouthguards are not used in live NFL games, but they are part of pilot programs, especially for offensive and defensive linemen. The long-term goal is to better understand which kinds of hits lead to CTE and other brain trauma. What about the cleats? They've got technology too. Some cleats being prototyped now include pressure sensors embedded in the insoles. These can measure force distribution across the foot, cutting angles and pivot torque, load during push-off, and acceleration. Teams can use this to assess running mechanics, diagnose inefficiencies, or track fatigue by analyzing changes in gait over time. These cleats are still in experimental phase and are mostly being tested in training environments. And yes, even the ball is getting smarter. Wilson, in collaboration with the NFL, has tested footballs embedded with RFID chips similar to those in players' pads. These chips can measure velocity, spin rate, trajectory, ball placement. In broadcast, this data can be already used in events like the Pro Bowl Skill Challenge, but in-game use is still limited. The big innovation would be with optical ball spotting like we mentioned before, where cameras and chips can automatically track where the ball lands. This will eliminate the need for referees to eyeball the spot, or for chain gang crews to measure first downs manually. And while it will be used in regular season play, officials will still be responsible for spotting the ball. Technology hasn't just transformed the fan experience or player equipment. It's also changed the way coaches strategize, prepare, and make real-time decisions. In 2014, the NFL replaced printed play sheets and black and white photos with Microsoft Surface tablets. These aren't just glorified e-readers, they're customized tools that let coaches review high-res stills of each play from multiple angles, annotate images with a stylus, organize footage by down and distance. However, video playback is still tightly restricted. Live video is not allowed on the tablets during games. Coaches and players can only view still frames captured moments after each play. The NFL strictly limits this to maintain fairness and avoid real-time strategic advantages. Video is only available in a few approved situations, such as replay reviews for officials or during limited injury assessments. That limitation has drawn criticism from some coaches, including Bill Belichick, who has publicly ditched the tablets in favor of traditional printed materials. But for most teams, the ability to quickly scroll, annotate, and compare angles still makes the Surface a key sideline tool. Oh yeah, and Microsoft reportedly pays over $100 million for its partnership with the NFL. Aside from the tablets, each NFL team is allowed one offensive player and one defensive player to wear a radio-equipped helmet. These helmets receive live audio from the sideline, usually from the offensive or defensive coordinator, but the system is strictly one way. Players cannot respond. Here's how it works. The communication is routed through a detected radio frequency managed by the NFL. A bone conduction earpiece inside the helmet transmits sound directly through the player's skull, so they can hear even in deafening stadiums. And communication is automatically cut off at 15 seconds left on the play clock, forcing teams to get calls in fast. The radio setup was first introduced in 1994 for quarterbacks after decades of debate about whether technological assistance on the field violated the spirit of the game. Defensive helmet comms weren't allowed until 2008. A small green dot is now given on the back of the helmet, signifying that a player is wearing a radio. The NFL's primary communications provider is Motorola Solutions, which has equipped sidelines and headsets league-wide for decades. Motorola builds the league's custom radio systems, and they include military-grade encryption, fail-safes, and frequency hopping protocols to prevent eavesdropping or interference. While the system is generally reliable, comms can and do fail. Signal dropouts have occurred in key games, leading to accusations of tampering. The most infamous case was in 2015, when the Steelers' headsets picked up the Patriots' local radio broadcast during a game in Foxborough. Many believed it was no coincidence, given the Patriots' history with Spygate and Deflategate. The NFL ultimately blamed the issue on weather and stadium wiring, but it remains one of the league's most suspicious tech incidents. While only 2 players can have helmet radios, the entire coaching infrastructure is connected. Head coaches, coordinators, quarterback coaches, position coaches, upstairs analysts, and spotters all wear headsets, wired or wireless, linked to encrypted comms networks. The coach-to-coach comms are often just as critical as helmet radios. It's how coordinators in the booth relay coverage tendencies, how replay assistants request a challenge, and how position groups adjust mid-series. There's a growing conversation about expanding comms to more players. Some propose giving helmet radios to safeties or middle linebackers to improve defensive cohesion. Others argue that multiple offensive linemen or even wide receivers could benefit from live coaching with input. So far, the league has resisted expanding access, fearing overcoaching, comms abuse, or an arms race in live play adjustments. But the idea isn't dead. The XFL has tested multiplayer comms, and the NFL often watches those experiments closely. As with most tech in the NFL, it's not a matter of if it will be adopted, just when. Overall, there is a ton of technology in the NFL, much more than fans probably realize. It is incredibly important to the game we love, and future innovations will continue to improve the game over time, preventing injury, speeding up on-field calls, and improving the viewer's experience at home. What's next for the future of NFL tech? Visors that show the play call? Perhaps in the future. But for some of the technology we've discussed, it appears the future is already here.